Good day, everyone. We are Group 1, and our inclusive design is Smart Shoes, or as we name them, AdaptoSole, revolutionizing mobility with inclusive smart footwear. Next slide, please. So, for our abstract, this project is dedicated to developing an inclusive product, specifically adaptive smart shoes, which meticulously tailored to meet the diverse needs of individuals with mobility impairments. The design process is centered on fostering independence and accessibility, guided by user-centric principles that transcends physical limitations. These innovative shoes integrate embedded pressure sensors and smart insoles, dynamically adjusting their firmness and support in users' unique walking patterns to help with their balance and help stabilize their walking patterns. Designed with a keen focus on inclusivity, the shoes seamlessly adapt to different terrains, delivering stability and heightened comfort. Furthering enhancing accessibility, the design incorporates easy slip-on features and a universally accommodating fit, which ensures a user-friendly experience for individuals with diverse mobility needs. Through an empathetic and collaborative design approach, this project aims to contribute to the creation of an inclusive and supportive environment, ultimately enriching the lives of those with mobility impairments. So let us now move on to phase 1.
So I will now discuss the documentation research of the chosen topic. So designing AdaptoSole for inclusivity. The name AdaptoSole is a combination of the words adaptive and soul. The term adaptive highlights the adaptive technologies, while sole refers to the bottom part of the shoe, making it a central and crucial element of the design, reason why we came up with this title. So the design is crafted to resemble normal-looking shoes because we want to ensure that individuals wearing them can blend in without drawing attention. So the goal is to make individuals with mobility impairment feel comfortable and normal. So the problem is that many individuals with mobility impairments face challenges such as instability, discomfort, and many more, limiting their overall mobility and independence. So this design offers a solution by integrating adaptive technologies, including pressure sensors and smart insoles. In order to build our design, we have to identify the issues. We should pay close attention to walking patterns, balance issues, terrain adaptability, foot sensitivities, assistive device interaction, and user preferences. So this would be our design's products or our design's target market. So we have people with problems walking, older adults experiencing fatigue while walking, individuals with arthritis, people with joint problems, individuals recovering from stroke, post-surgery walking challenges, and people with walking difficulties due to spinal issues. Let us now proceed to our phase 2, which is the concept and storyboard. Before we proceed to our concept, this would be our key features of our designs. So we have embedded pressure sensors, smart insoles, balance enhancement mechanism, terrain adaptability, easy slip-on features, universally accommodating fit, and material selection. For our first concept, I came up with the idea of creating smart shoes with an asymmetrical platform. So these platforms are adjustable based on the user's leg length, height, and body posture. It also has smart insoles that can adapt from the user's body weight and walking patterns. In our problem scenario, we have a woman with leg length discrepancy and is having a hard time walking because of her unbalanced posture. And as you can see, the solution is that by wearing this type of shoes, they can maintain their balance, disregard the usage of canes and crutches, and live a normal life like other people. Let us now proceed to concept number 2.
So for our concept number 2, I was inspired by the design of Nike with the self-lacing feature, in which in our embedded sensors can detect whether or not the person with mobility impairments needs their shoes to be more fit. So with that, once it detects that it is a bit loose, the lace will automatically tighten. Therefore, it will fit into the person's shoes, and with the embedded sensors, it can also detect for abnormal movements in which it can adjust. It is durable and comfortable since it is made by synthetic and has a foam which can actually one pressure into the heel movement of the person. So for my problem solution scenario would be a person with plantar fasciitis. So long fasciitis is actually healing, in which when a person does long walking or goes up the stairs, the constant pressure on the heel can lead to discomfort and pain. So with our shoes, this actually help the person feel more at ease and comfortable, since once it detects that the heel has too much pressure while walking, it will not put provides more comfortability to the person. So let's move on to number.
For the third concept of AdaptoSole shoes, the design seamlessly merges aesthetics with a convenient slip-on feature, a precision balance enhancement mechanism, and intelligent pressure sensors that detect weight pressure and shifts in distribution, ensuring a consistently upright and balanced posture. The breathable text lining prioritizes lightweight comfort, preventing excess sweating. Additionally, the shoes feature an innovative inflatable foam that dynamically adjusts to the user's feet, addressing balance impairments. These shoes are rechargeable via a magnetic USB cable akin to the charging mechanism seen in smartwatches. Next slide. In the depicted scenario, an elderly man faces challenges with walking, struggling to bend down and tie his untied shoelace while experiencing foot pain. The transformative solution lies in the innovative of smart shoes. These intelligent footwear not only correct balance impairments but also address various health issues related to walking. With the aid of these smart shoes, the old man regains the ability to walk effortlessly and comfortably, significantly improving his overall mobility and well-being. Next slide.
So for our phase 3, we will be determining the final design solution. Next slide. So this is actually our final design. We incorporated concept number 2 and concept number 3 together, but we made some adjustments such as thickening the sole of the shoes, since we'll be adding built-in sensors plus the soles and even the foam to ensure that everything is in place. And we made the material breathable, and also we incorporated the self-lacing from concept number 2 to ensure that the shoe will really fit into the person's foot outline. So for our materials, next slide. So for our materials, we'll be using rubber, synthetic knit, built-in sensors, and foam. With these materials, it can ensure that it will be durable, lightweight, and comfortable for the person with mobility impairments. Next slide. So for our problem solution scenario, so we have someone with uneven leg length, which affects their posture and balance, and then another one with spinal issues, which can affect the person's walking movements. So once they wear our AdaptoSole, it can come and ease. Well, let's move on to phase 4.
For phase 4, we will discuss the digital renderings, product in use, team design portfolio for inclusive design. Next slide. Showing the product in various views and angles, details, and product in use using applicable programs. This is the shoes in different angles. And then next slide, please. Here are the shoes in an in use scenario. The shoes provide comfortability to the person's feet and can help detect any abnormalities. Next slide. In abnormalities in movements or feet discrepancies, such as uneven leg length, plantar fasciitis, and many more. Once the built-in sensors detect any abnormality, it will automatically adjust and even out the pressure to prevent the person from experiencing discomfort and pain. We ensure that with our materials, it is lightweight and durable so that people can make it as their everyday shoes. Next.
So once again, this is AdaptoSole, our inclusive design, and we are Group 1. Thank you so much for listening.